All right, we are on lesson 6.5 on systems of linear inequalities for algebra 2. Let me try that again. Systems of linear inequalities for algebra 2. So there's a couple words that we'll define before we start working with them. The first is constraints. These are just sort of like rules or guidelines or limitations. The next is vertices. These are the corners of the feasible region. This we will define here in just a second. But the vertices are the corners of the feasible region. The feasible region is the set of all points that are solutions in our system of inequalities. So this feasible region is the set of all points or coordinates that are solutions in our system of inequalities. Remember, a system means two or more, so we'll have two or more inequalities, and the feasible region is a space that holds those solutions. So then there's dotted versus solid boundary lines. Dotted, you're gonna have a dotted line if you have the less than or the greater than symbol. That means that you don't include the points on the line. So if it's dotted, you use these two symbols, or if you have those two symbols, you'll use a dotted line, and it means don't include those that are on the line. A solid boundary line will be if you have less than or equal to, greater than or equal to. In this case, it means that the points on the line are included. And then the last term or phrase, I guess, is reversing the direction of an inequality. So if you start with a greater than symbol, the only time that you will end with a less than symbol is if you multiply or divide by a negative. I can get into more of an explanation why if you ask me during class, but just to keep the notes simple, you will switch from this to this if you multiply or divide by a negative number. Just so you can kind of see these things in action, if you have a coordinate plane, you might have one inequality like this, another like this, and a third like this. Your feasible region is in here. That's where they might all be true, depending on how they shade. But just for an example, this in black might be the feasible region. These are then the vertices, because that's what kind of makes that feasible region. Okay. This feasible region will depend on where the shading goes. And for the orange line, those dots on the line would be included. Same with the purple, but the coordinates on this red line would not be included because it's a dotted line. All right, so let's look at a couple examples here. We want to solve for y, so we want to get y by itself. So the first thing we'll do is get rid of this. So what I would do is I would minus 12x on both sides. So we have chunga chunga, negative 6y is greater than or equal to 18 minus 12x. Then I would divide by negative 6, divide by negative 6, divide by negative 6. These chunga chunga, so we get y. This is negative 3, and then this is positive 2x because the signs change. Now, our symbol changes to less than or equal to. This changes, and again, that's because we divided by a negative. We divided by a negative. All right, over here, what I would do first is I would subtract 3. So we get 5 times x minus 4 is less than 20. Then I wouldn't distribute. I know you guys usually do. You certainly can. You'll be fine. But I'm just going to divide by 5 because these chunga, so I'm left with x minus 4 is less than 4. And then we need to add 4 to both sides. Chunga, x is less than 8. So this one did not change because we did not divide by a negative. Over here, the problem was dividing by a negative. That's why it switched. Here we divided by a positive, positive, so it stayed the same. Okay? You can always check, put in a number that's less than 8, like 0. 5 times 0 minus 4, 5 times negative 4 is negative 20. Negative 20 plus 3 is negative 17. And negative 17 is less than 23. I just mean choose an x, put it in, test it out. Okay, so let's graph one of these. It says graph the inequality y is greater than or equal to. This one is greater than or equal to. So first thing we do is we start with the y-intercept, which is negative 4. So we're going to go 1, 2, 3, 4, down. Our slope is 2, so like 2 over 1, rise 2, run 1, rise 2, run 1. Or down 2, back 1, down 2, back 1. Now, don't just connect it. We have to ask, do we have this or do we have this? Well, if you have this one, we're going to use a solid line. If we've got this, we're going to use a dotted line. We've got this one, so we're going to use a solid line. Now, this is the weird thing. We need to test a number. So what I usually do is I want to see which of these numbers will end up having a y value greater than this side. You'll start to see a pattern, but there's a whole set of solutions here because we're talking more than or less than. So typically what I do, I choose the same point if I can. I choose 0, 0. So when I choose 0, 0, I make sure it's not on the line, first of all. And then I take and I put this in. Y is 0. And I ask, is that greater than or equal to negative 4 plus 2 times 0? Well, this side is negative 4 plus 0. Is 0 bigger than negative 4? Like, is that eating the appropriate number? Is it eating 0? Should it be eating 0? Yes. So since I tested this number right here and it worked, that means this is our feasible region. This is our like successful region, okay? If you had tested that and it was a no, if this was a sad face, it was a no, just automatically shade the other side. You only need to test one point. If it's true, shade that side. If it's false, shade the other side. We are going to skip this one for now. If you want, we can talk about it later. We're going to do a section on that after this. We're going to do that in 662. So I'll do this one, and then I'm going to pause, and we'll use a new video for the last couple examples. So this one says, graph the feasible region of this system of inequalities. It says x is less than or equal to 3. So if x is, here's 3. If x is less than or equal to that, equals means solid line. Less than would be this direction. Then y is less than or equal to 5. So 1, 2, 3, 4, 5. Here's y. And it's equal, so it's solid. And that would be this direction. Y is greater than or equal to 0.